Alright guys, welcome back to Underground Science, and in this video we're just going to continue talking about naming alkanes. Alright, and we'll dive straight into examples also like we've been doing. So let's dive into an example. Let's go ahead and draw an 8 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. And then let's go ahead and put this here, right? And one there. Alright, and let's just try to name this. So previously we've been mostly dealing with like one substituent, right? So now let's try to focus more on more than one substituents. All right, so for this one, again, what's our first step? We focus on naming the longest parent chain. So what would be the longest parent chain here? So let's start here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, or I can do 1, 2, 3, 4, 5, 6, 7, 8. But if you noticed, the gray and the orange is the same exact thing, so we're just going to keep the orange and just not do the gray. But you could do the gray, it's the same thing. What other ways could you name this, right? Could you go about naming this? So you could also do 1, 2, 3, 4, 5. But right there, like you can immediately tell like that's not right. So let's not do that. Okay, so it looks like we have the longest parent chain numbering. But what you also want to do is you want to make sure if you have, remember, if when we had one substituent, we wanted that substituent to be on the lowest carbon number. The same thing goes with more than one substituent. If you have two substituents like you do in here, right? So let's point that out. You have one substituent here and one substituent here. If you have two substituents, you do the same thing. You want those two substituents to be on the two lowest carbons possible. So the other way to number this, right, if you want to actually compare, would be from this side. So you would start 1, 2, 3, 4, 5, 6, 7, 8. Okay, which numbering is correct? Well, let's take the brown for example. At what carbon numbers do you have the substituents on? So for the brown, right? For the brown numbering, we have the substituents on carbon number, this carbon right here, which is carbon number 5 for the brown numbering, right? And we have a substituent right here, right? So what carbon number would that be for the brown numbering? That would be carbon number 6. So we have 5 and 6, all right? Now let's take the orange numbering. At what substituents, or what substituents on which carbon numbers do we have for the orange numbering? So if we take orange right here, we have a substituent here, which is number 3 for orange, carbon number 3. And then we have a substituent here, which is carbon number 4 for orange. Okay, so actually let's be consistent, write the number sign on it so we know. So which color do you think contains the smaller numbers? So wouldn't you say that numbers 3 and 4 is less than numbers 5 and 6? Right? Wouldn't you say that actually to be consistent, what we should do, right, is say 3 and 4 with orange, because that's what we wrote up there. So that's true, right? This statement is true. 3 and 4 is less than 5 and 6. So you choose the numbering that's in orange, because that's going to give you the substituents on the least number of carbons, which is 3 and 4 as compared to 5 and 6 for brown. So the numbering that we want to go with, right, is orange. So let's go and erase the brown, because that's not the numbering we want, and we want the orange numbering. Now that we know that, it's easy to name the molecule, right? So we have a methyl coming off the 4th carbon, so that's 4-methyl, right? And then we have an ethyl substituent coming off the 3rd carbon, so that's 3-ethyl. And then what's our parent chain, our longest parent chain? It's an alkane, which is 8 carbons, which is octane. So ethyl octane. Alright, so that is our name of this molecule. Now I hope you guys noticed something wrong with this, because this is not in alphabetical order. This is not the correct way to write it. So if you guys know, right, E comes before M in the alphabet. So in fact, the correct way to write this would be 3-ethyl 4-methyl octane, right? So let's go and erase this because this is not the correct way. And why? Because we didn't write in alphabetical order. Okay, you always write these in alphabetical order according to IUPAC, right? So that this is the correct molecule name. All right, so let's go to another example. So let's say in this example, we consider alkyl halides, right? So this shouldn't be that bad that now that we've dealt with a lot of examples previously. So when we're looking at alkyl halides, right, or alkyl halides, alkyl just means a carbon chain, and halides, right, you see this part of the word hal, so that should that signifies halogens, right? And so if we pull up the periodic table, right, so these right here in this row, let me go ahead and draw that out or outline it. These are your halogens, okay? So again, what are these? These are your halogens. Okay, so knowing that, alkyl just means a carbon chain, okay? So you have a halogen off of a carbon chain, which is called an alkyl halide. So if we go and look at an example, let's say we have something like that, and off of this, right, we have a bromine, or we can even look at like a chlorine over here, or any of the halogens that we just pointed out. But if we go and look at this, right, let's say this is, we also have something like this right here. Again, what do you do when you name an alkane? You identify the longest parent chain, and you make sure that the substituents are on the lowest number of carbon. So if we start here, the longest parent chain with the substituents being on the lowest carbon will be from here. So 1, 2, 3, 4, 5, 6. And if you wanted to, we can go over this too. 1, 2, 3, 4, 5, 6. Now we'll be a little quicker with this because we've already done it. So if we look at the gray numbering, right, what carbon numbers do we have substituents on? So that'll be numbers 3 and numbers 5, or number 5, right? And if we look at the orange numbering, what carbon numbers do we have substituents on? That would be number 2 and number 4. So 2 and 4 is less than 3 and 5. That's why we go with the orange numbering. So let's go ahead and erase the gray numbering, right? And let's go ahead and name our molecule with the orange numbering. And from here it's easy because now you have to keep in mind alphabeticity, right? So let's erase this for now. We'll go to this example next. I mean, it's the same thing. Once we get down this example, we'll know that too. But you have to focus on alphabetical order now. So we have, what do we have? We have a 2-bromo, and we also have a 4-methyl, right? So B comes before M, right? So that's why we would say, we would list the bromo first. And another thing to point out before we start writing the molecule name is that this is a 6-carbon chain. So what would that be? That would be hexane, right? As our parent chain, alkane. So if we write the final product in alphabetical order, that would be 2-bromo, 4-methyl, hexane. All right. So that's alkyl halides, and you can do the same thing. Once you know this process, you can name other alkyl halides too, right? So for example, if we just did one more, we can look at this molecule right here. So 1, 2, 3, 4, 5, 6, 7, 8. These are just random, like any chain would do, basically. And then let's say I put a bromine here. Let's say I put a bromine here. Let's say I put a bromine here, right? So what would this molecule be? Same thing, doesn't matter how many substituents. You say, okay, what's the longest carbon chain? And I need to number it so that the least carbon numbers are on the substituents, or the substituents are on the least carbon numbers. So let's start from here. 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8, right? So okay, what numbers on the orange numbering, what carbon numbers have substituents on them? Okay, so let's take a note of that. So we have carbon number 4 with a substituent, and carbon number 3 with a substituent, and carbon number 2 with a substituent, which is all bromine, right? And then for the gray, let's do the same thing. Which carbon numbers have substituents on it? So we have carbon number 7, we have carbon number 6, and we have carbon number 5, right? Now, what would you say is lower, 2, 3, and 4, or 5, 6, and 7? So obviously, 2, 3, and 4 are lower. So we would choose the carbon numbering pattern in which, or we would choose the numbering pattern in which the least number carbon has substituents on it, which is 2, 3, and 4, rather, compared to 5, 6, and 7. So let's go and erase the gray numbering, since that one is not the least carbon numbers. All right, so let's go and erase the gray. All right, and now let's go and name the molecule. So let's pay attention to the longest parent chain, which is 8 carbons, which would be what? Octane, right? And we have a 3-bromo, so let's list it out. So what do we have? We have a 2-bromo, we have a 3-bromo, and we have a 4-bromo. Well, what would we name that, right? So it'd be 2, 3. So if you join this together, you would do 2, or you would get 2, 3, 4, tribromo, right? Tri meaning 3. As we know that mono, right? Mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, and so on. All right? So if we're naming this molecule, it would be 2, 3, 4, tribromo, because there's 3 bromines, right? Tribromo octane. That's it, done. So it doesn't matter how many halogens are coming off, right, of the parent chain. How many ever halogens are coming off, how many ever substituents, just follow this normal pattern that we've been doing, and you should get to the answer. All right, so if you want, we can do one more, and we can just put in different halogens in there, right, just to work this process more. So if you want, we can, let's say we can even make this chain longer if you want, right? We can put a bromine here and a chlorine here, right, and a bromine here, and name this. So what would this molecule be? So if we look at it right away, what do? We number the longest parent chain. Okay, so what would that be? Let's start here. 1, 2, 3, 4, 5, 6, 7, 8. Right? What's the other way? 1, 2, 3, 4, 5, 6, 7, 8. Again, you guys probably already know this, right? It's probably going to be repetitive, but let's keep on doing it. Choose the numbering pattern that has the substituents on the least carbon numbers. So if we start with gray, right, what carbon numbers does gray have substituents on? Right, so we have a substituent on carbon number 2 for gray, right, which is right here. So let's write that down. 2, what else? 4 and 6. This is for gray. What about for orange? For orange, we have substituents on carbon 3 and carbon number 5 and carbon number 7. So what numbers do you think are lower overall? 2, 4, and 6, or 3, 5, and 7? Well, the answer is 2, 4, and 6, right? So we can erase the orange numbering and keep the gray numbering, since the gray numbering would be the least carbon numbers that have substituents on them. Substituents, right? So let's go and erase the orange. All right, and now we just go and name the molecule. So remember, so we can get rid of this since we know the numbering, right? And what we have to pay attention to now is alphabetical order. So what do we have here? We have 2-bromo, we have a 4-chloro, right, because of chlorine, and we have a 6-bromo. Okay, so looking at this, how would you name it, right? How do we put this together? And we also have an 8-carbon chain octane, right, or alkane, which is 8 carbons is octane. So we also have an octane. All right, so putting that together in alphabetical order, we have 2-bromo, right? But we also have a 6-bromo, so we can combine them, and we know bromo comes first in the name because B comes before C, right? If we're comparing bromine to chlorine alphabetically. So it'd be 2, 6, because it's bromine on each one, right? On 2 and the 6 carbon, you would say dibromo. So it'd be 2, 6, dibromo, Then you'd bring the chlorine in, so 4-chlorooctane. Okay, so octane. And I know it's gonna seem weird, like, oh, are you sure this is right? Because there's 2 O's here. But we're following the same rules, right? As if, I mean, if this was, let's say, pentane, right? I mean, this is not a pentane molecule, but let's say if we wrote pentane here, then it would be correct. And if this is correct, it's also correct if we write octane, right? So you don't have to worry about the 2 O's there. All right, so this is the last, or this is the final product, or naming the final product. And so that's it for this video. In the next video, we'll talk about a few examples of naming cycloalkanes, and then from there, we'll probably move on to naming alkenes. So see you guys in the next video.